Okay, so what we were talking about until now, we tried to compare monolith versus microservices, and then we looked at what are the challenges associated with developing microservices, right? So, trying to develop small components which are individually declarable and also independently scalable, dynamically scalable is not an easy thing. I mean, there are a lot of challenges that we talked about. Now we'll look at some of the solutions to like the problems that we talked about. So the microservices challenges that we talked about. What are the different solutions that are present? I mean, the solutions that we'll be talking about are more into the Java space. So yeah, that's kind of a disclaimer. One of the important things which came in end of 2014, 2015, and it's very, very popular now is Spring Boot, right? So, can anybody tell me what is Spring, right? What is the thing that Spring brings into you? So why does Spring become so famous? Right. So you have dependency injection, right? So what do you get by dependency injection? Testability. I think one of the most important reasons is that testability, right? So earlier when we developed applications, writing unit tests for them is impossible, right? So when I go back 15 years and look at the applications which I wrote, I'll laugh at it today, right? Because like each time I have to test something, I have to deploy, run through the screens, and then check whether it's working or not. So that's the kind of code that I wrote 15 years back myself. So that's the kind of environment in which Spring Framework came in, and like with Spring, writing unit tests became like a cakewalk, right? So today we are in such a state where, like, to write a unit test, I don't really need to write a lot of plumbing code. So I can just say, like, start with unit test and easily write code. One of the important frameworks in that journey was Spring, because it brought in dependency injection, inversion of control, and made testability possible, and therefore unit testing became very easy, right? So after that, there was other web frameworks. Spring MVC was one of the popular ones, right? So, and also, like, slowly we then Spring Boot came, right? So what is Spring Boot? Can anybody try and define what Spring Boot is? Less declarative architecture. Any other? Rapid development. Easy configuration.
Conventional approach.
Sorry? Conventional approach to development. Minimal code. Right? So,
you don't worry about how you configure your system rather than you work on your.
Yeah. So, basically, this is what Spring Boot says is, I mean, pivotal says the aim of Spring Boot is, right? So, it's to enable production-ready applications quickly. So you want to be able to develop a production-ready application very, very quickly, right? What do you mean by a production-ready application, right? So it's not just code, right? Typical application is not just code, right? You need a lot of things that are present in the application before you'll be able to take the application live. So Spring Boot wants to be able to enable you to develop such kind of applications very, very easily. Let's quickly look at something. So when we talk about production-ready applications, one of the most important things is not just the functional features, but also the non-functional features, right? We are talking about being able to use an embedded server, right? So what is an embedded server? Does anybody? What is an embedded server? It has its own container. It comes. Exactly. So typically we are, like, when we create applications, let's say I'm using WebSphere, let's say. So typically I need the server installed on my machine, and then I create a var and deploy it inside the server, right? So that's typically how we do things. But with frameworks which support embedded servers, what happens is the server becomes part of your application. Like it's almost like a jar in your application. Just like you have a spring.jar, you would have a tomcat.jar. Not as simple as that, but that's kind of the concept, right? So your jar is part of your application. Why is the reason why embedded servers are very, very important is again the shift towards containers and things like that, right? So you want to be able to easily deploy your application. Having a separate server installed on the machine is an additional step which you don't really need to worry about. So if your application itself can run on its own without needing a server, that's what, like, you don't need the server. So that makes it much more easier because the entire infrastructure that your server needs, like let's say for example, I would want to install WebSphere, that might be a GB, a little more than that maybe. So all that you would not need to do. So you can directly take the application and run it. All that you need installed on the machine is Java. So once you have Java 8 installed, you can, once you have Java installed, you can go and run your application directly on that particular machine. So that's why embedded servers are important. The other non-functional features which you typically require are metrics, right? How many times a service is hit, how many times a fault response is coming back, all that kind of metrics and monitoring. And you want health checks around the application, right? So you want to be able to know whether it's up or down, all that kind of stuff, and externalized configuration, right? So you want to be able to define like what are the other services you want to talk to, what are the other business-related configurations that you need to have in the application, all that kind of stuff you want to be able to have as a feature in your application. So these are some of the non-functional features which are provided by Spring Boot. Let's look at a this is basically just to give you an overview of the kind of configuration that we had in applications before, right? So if you look at Spring Framework, the most important feature that we talked about was dependency injection, and basically this is what we were doing before, right? So we were directly instantiating something instead of so to unit test this service is very, very difficult right now because you are directly creating an instance of the new welcome service here. Instead of that, what we do with Spring is we make it at auto-bind. That means you can actually pass in a different service and you'll be able to unit test this very easily. So you can auto-wire in something else and you'll be able to easily do stuff. So when it comes to typical Spring applications, this was what we were doing a lot of, earlier. Before Spring Boot, we had to write in a lot of configuration. For example, this is for a typical web application. This is how we configure a view resolver, right? And I'm configuring web jars down below. And this is just an example, right? So you need to configure, like for example, in the web.xml, I need to configure a dispatcher servlet and configure the URL to it. And if you are actually trying to connect to a database and you want to, you need to create a data source, then you need to actually create an entity manager. If you're using JPA, you would create an entity. So all this kind of configuration is needed typically when you would actually create any application with. Is this good? Okay. So all this kind of configuration is typically needed whenever I wanted to create an application. So there was a lot of XML, which was like, I worked in applications where, like before annotations, the XMLs were really, really huge, right? So I was working in applications which had thousands and thousands lines of XML configuration. But what happened after that was with annotations, the amount of configuration that was needed got reduced, but still there was a lot of configuration that you needed to do, like data sources. Like if you had to interact with another framework, you need to configure a few things. Hibernate, let's say JPA. You need to configure the entity manager, transaction manager, and all that kind of stuff. So these kind of XML, you want to start. Typically, we used to do that for every project. So what Spring Boot says is, can we really think differently, right? So can we say, like, if somebody is adding a Hibernate jar, then what is the reason why he is adding a Hibernate jar into the class path? The reason why he is adding a Hibernate jar is because he wants to talk to a database, right? Why don't I provide a data source by default? Why don't I do things by default? Why don't I create an entity manager by default? So that's kind of the thinking that Spring Boot auto configuration brings in, right? So how about auto configuring a data source if Hibernate is on the class path? How about auto configuring a dispatcher servlet if Spring MVC is on the class path? And basically what Spring Boot does is as soon as you add libraries, as soon as you add components into your class path, it looks at them and it identifies what is the configuration that you might need. There is always a possibility of overriding that. That's always there. But Spring Boot by default looks at whatever is present. For example, if you are adding a Spring MVC jar into the class path, Spring MVC sees that and it says, okay, this guy is trying to he's trying to develop a web application. So I'll provide a view resolver by default. I'll provide WebJar configuration by default. I'll probably provide validation configuration by default. So all this kind of stuff Spring Boot would provide to you by default. So you don't really need to go and configure anything for validation. You can directly start writing your business logic. So that's one. The second important thing about Spring Boot is something called Spring Boot starter projects, right? So what Spring Boot does. What Spring Boot says is, like, when I develop a web application, typically what I would need to do is I need a lot of these kind of jars, right? I would need Spring MVC, Spring Web MVC jar. I would need Jackson data bind. So if you want to bind whatever JSON is coming to your Java, so you need a Jackson data bind. You need Hibernate Validator. That is typically the only beam validation implementation, popular one. So first thing is this one. That's okay. So if you look at the Hibernate validator which is mentioned in here, it's little different from the Hibernate JPA thing, right? So this Hibernate validator is used to validate whether you are. This Hibernate validator, which we are talking about, is to validate, like when a JSON comes in, you want to do a few initial validations. That's where it is. The API is beam validation API, and Hibernate validator is one of the implementations of that. Switch to this. So the Hibernate validator, you need some logging. So all that kind of stuff you would need. So you need to configure all these dependencies in your pond.xml, right? So what Spring Boot says is, okay, when somebody is trying to develop a web application, almost every time he needs all these jars, right? So Spring Boot provides something called a starter. So these starters are basically deployment like pond.xmls, right? So they define a number of dependencies. The great thing about these starters is these dependencies work well with each other. Typically what happens is when I'm trying to work out, okay, I'm going to use Spring version 5. I need to go and manually and find out what is the right version of the Hibernate validator to use, what is the right version of Jackson data bind to use. And typically you would have this jar like mismatch problems, right? So because the version is not matching, you get some unrelated error which you try and go and search in Google and find out. I've spent a lot of time. So that kind of problems you can avoid, because Spring Boot starters would define the right versions for each of your dependencies. So if you look at Spring Boot starter web, which is one of the dependencies which is present, these are all the dependencies that it brings in. So if you look at it, it brings in the basic, it brings in all the Spring Boot starter configuration. It brings in a lot of logging stuff here. And there are a lot of Tomcat, embedded Tomcat things which come in as well. There is validation, and there are data binding stuff, and also things like, and the basic Spring stuff, right? AOP, beans, scores. So as soon as you just add a single dependency for a starter, you get all that for free. So you get all the jars directly in your class path. And Spring Boot actually provides a wide variety of starters, like whether you're developing a web application, a JPA application, or you want to do Helios, or you want to implement a data JPA. There are wide varieties of stuff that are present. Other than this, Spring Boot also provides a lot of technical starters, right? So there is something called Actuator, which helps you to monitor applications very easily, and you would have a lot of other. Okay. So there are a lot of other starters which are provided by Spring Boot, like Spring Boot Starter Actuator, Undertow, Jetty, and Tomcat. These are more the embedded server specific ones. If you don't want to use Tomcat, then you can use the other stuff as well. And you have logging related starters and stuff like that. Okay, let's now quickly create a small Spring Boot application. So the start of Spring.io is like a simple website where you can go and create Spring Boot projects. So all that you need to do is type in. I mean, actually, I can even do this from Eclipse and a lot of other IDEs as well. IntelliJ, NetBeans, all the IDEs you can use to create this project. Or you can go into start.spring.io and let's just say com.example.test, and let's call this microservices demo. You can actually choose which build system you want to use. You want to use Maven or Gradle. And also, Spring Boot provides a choice of languages as well. The latest edition is Kotlin. Like you can develop Spring Boot applications with Kotlin as well. So if you are good at Kotlin, that's a good choice as well. So Java, and I'll use one of the Spring Boot versions. So I want to use one of the latest versions of Spring Boot. So I'll go for 2.0 and 3. And this is where the Spring Boot magic, the Spring Boot starters can be added in. So when this is typical, right? So you are giving basically a package name kind of thing, a group ID, a artifact ID, and you can add what dependencies that you would want. So over here, the dependencies, for example, I would want to develop a simple web service. So the suggested starter is web, and let's say I would want to use JPA to talk to the database. And let's say I don't really want to connect to a real database. I would want to connect to an in-memory database, so I'll put in H2. So H2 is in-memory database in the sense that it runs within your app, within the JVM. So you don't really need to start the database outside. So it starts with the application and ends with the application as well. So it's more like all the data is lost between restarts, but it's a nice database if you want to quickly learn something, you want to quickly experiment something. H2 is a good thing. So what I've done until now is just provided a group ID, artifact ID, and said web and JPA and H2. That's it. I can go ahead and generate the project now. So the project is downloaded. And what I'll do is I'll import this into Eclipse. So I'll go ahead and do a file import existing Maven projects. Let's browse to the downloads folder. And this is the thing. Oops. It's showing 2:28 p.m. I'll delete this just to be safe. I'll generate it again. So I'm basically extracting that zip which is downloaded and I'll import it into Eclipse. So if you look at the pond.xml of the created project, all that it would have is all the stuff that we have selected, right? So we selected JPA. So the starter for that is starter data JPA. We selected web application. The starter for that is starter web. And we choose H2. And the starter test is added in by default because any applications that you do, you would want to write unit tests. So Spring Boot directly adds in, Spring Initialization directly adds in a dependency on the Spring Boot starter test. So I have a few other applications which are running already here. So one of the cool provisions that Spring Boot provides is you can directly type in configuration into something called application.properties. So I'm changing the server.port just to be able to run this on a different port. So what we have in the application that we created is a simple Java class. This is the Java class that is present. And we have a pond.xml defining the dependencies that we saw here. So if you look at this demo application, there is not a lot on it except for an annotation for Spring Boot application. Let's not get deep into it. What I'll try and do is quickly create a simple service over here, right? So let's create a simple service. So let's just call it I'll make it a REST controller. And let's just quickly create a get mapping. Meeting. So I'm just writing a simple method very easily. I just create a class called greeting. Private. I'm just generating a few getters and setters as well as toString. And now I can actually just create a toString with the greeting as well. So basically what we're trying to do here is create a very simple controller, and I'll import the get mapping in. So that's all I would need, and now I can go ahead and run this application. So I can go ahead and say right click, this is the the microservice demo application. You can do run as Java application, and it will launch up. And you can see that it's launched up on port 9999. Let's see what's there. Localhost 9999 / what's the URL that we configure? Hello. So basically, you can see that without doing a lot of stuff, I have my first service up and running, right? With zero, all that I had to focus on was my business logic, and that's it. I have my service up and running. I did not worry about what frameworks I need to have. I do not worry about what configuration I would need to do and all that kind of stuff. So, like before this, like before Spring Boot, you had to do a lot of configuration to get things like this going. So this is one of the most important parts of like why Spring Boot, like people are choosing Spring Boot above others for microservices, because it helps you to quickly start up, right? So I don't really need to do a lot of configuration. I can quickly start up with a lot of things. So actually, it's like we have JPA on the class path as well. So if you need to create an entity, you can actually quickly say, let's quickly create an entity and see what would happen, right? So I want to create a user entity. I'll need to mark this as an entity because this is something which I would want JPA to manage. And let's create a simple string name. I'll just create a user name. I'll not do anything more than that. So I'll create the data set setters as well. And let's add an ID field. And generate data set setters for that as well. So basically what we have created is a simple entity which has an ID and a name. Sorry, a name and an ID, right? So I'll also create a simple constructor. Because there's an entity, Hybrid expects a default constructor as well. So I'll just quickly create an empty constructor. I can have this as private also, does not matter. Like Hybrid expects you to have, JPA expects you to have a empty constructor. So now we have a simple entity defined, right? So as soon as you have a simple entity defined, what Hibernate like does is, because we already added JPA into the class path, it actually understands the fact that you would want to create a table for it. Because I have in-memory database, H2 in the thing, I mean the class path, Hibernate picks that up and automatically does a few things. Let's quickly see that. Run that again. So if, oops. What we have done is we have added in a simple entity called user, and Hibernate, like the Spring Boot looks at this thing and it would automatically initialize the database. One of the things I have to do is enable the H2 console. Like I have, let's go to the application properties, and so I would enable something called H2 console where I would be able to see the data that is present in there. And I'll restart the application. So this is H2 data source, and you can also already see that there's a user table created in here. right? So there's a user table which is created in here just by creating an entity. So as soon as I created a user table there, the Spring Boot looks at it and says, okay, there's an entity, sorry, as soon as I created a user entity in there, and because H2 is in the database, Spring Boot recognizes, auto-configures a data source to connect to this, it will create a table, and it will do all the stuff which is needed. And Spring Data JPA provides very, very easy ways for you to query around these entities as well. So if you, let's say, want to create a simple repository class, so I can just need to say class user repository. Actually, it should be an interface. You can link. There are. Oops. I can say JPA. Repository.
Extend.
Sorry, it should be extend because it's an interface. So what we need to extend is a simple JPA repository, and you can specify what is the entity that you want to manage. The entity I would want to manage is user, and also let's say I would want to what's the primary key for that. So as soon as I do that, I specify the primary key for this is long, right? So I just do that, and I can say as repository. So what this provides me with is all the methods around typical things that you can do around the user entity. So here I'm actually auto-wiring this into the controller. And over here, let's say I would want to create another method. I can say public list of users, get all users, and I can say return repository dot find all. So this would return all the users which are present in the database. So basically what Spring Boot enables us to do is to create applications very easily, and it will help you to focus on the business logic. So you don't really need to worry about how to configure a framework, how to configure a data source, how to configure a JPA, entity manager or things like that. All that you need to do is start writing your code, and you'll be able to do stuff with it very easily. Right? So let's get back. We have 15 more minutes. We already looked at that. Key features we talked about: auto configuration, starter projects. Spring Cloud is what we look at right now. So one of the important things that we have been talking about until now is dynamic scale up and scale down, right? So you want your microservices to go up and go down you want to be able to dynamically scale up the services and bring them down when they are not needed anymore. But one of the important things about dynamic scaling up and scaling down is, let's say you have two services talking to each other, right? Service 1 is talking to service 2. If I take the URL of the service 2 and directly configure it in service 1, hardcode it in service 1, then the service 1 is always talking to a specific instance of service 2. Right? So if you bring up new instances of services, even though I have 5 instances of the service 1 is always talking to specific instance of the service 2. So one of the most important thing, if you want to be able to dynamically scale up and scale down, you want to be able to have the right architecture for doing that, and that's what Spring Cloud provides. Spring Cloud provides all the typical things that would be needed to enable all the cloud-related behavior, right? So dynamic scale up and scale down is one of the important things around that. So what we look at are three important things. One is a naming server, Eureka. Eureka is like one of the popular naming servers, which are like popular naming servers which is supported by Spring Boot. Naming servers are basically, you can think of naming servers like a registry, right? So a service comes up, it says, okay, I'm available. It puts its hands up. So let's say there are service 2, 5 instances of service 2 present. So all the 5 instances would register with Eureka. So, and whenever somebody wants to call service 2, you need to ask Eureka, okay, hey, I would want to call service 2, where is it present? And Eureka would tell it, okay, these are the 5 instances which are present in here. So that's the naming server. The other one is load balancing, right? So when you have 5 instances, you want to be able to distribute the load among all the 5. You don't want one instance to be hit all the time, right? So that's where Ribbon comes into picture. So Ribbon is a client-side load balancing framework. So I'm not going to the details. Basically, client-side load balancing means the service invoker, the consumer is doing the load balancing. So the load balancing is not done somewhere in between. It's basically the service consumer who's doing load balancing. There are a lot of discussions about which is better, the server side or the client side load balancing. Let's not get into it. Ribbon is one of the popular options. And the other thing is Feign. Feign is basically like, how many of you use REST templates to call services? So yeah, it's the most popular way which is supported, right? But when I use a REST template to call, there is a lot of plumbing code I would need to write. Right? Let's say the service has 15 fields, I need to write plumbing code for each one of them. So the Feign helps you to eliminate all that plumbing code and write very, very simple clients very, very easily. So basically Feign enables you to write very simple REST clients. The other important part when it comes to Spring Cloud is the visibility and the monitoring part, right? So one of the things is to be able to dynamically scale up and scale down. The other thing is to be able to find out problems very early. That's where visibility and monitoring comes into picture. So the things which provide visibility and monitoring are typically the gateways. So there is a Netflix API gateway which is present, and also it's Zool that we'll be using in here, and distributed tracing through ZipKit. So you'll be able to trace what is happening across the microservices. So a microservice 1 is calling 2, 2 is calling 3, all that kind of tracing you can do it through ZipKit distributed tracing. So. And the last important problem or challenge that we talked about was configuration management, right? So you have multiple services, managing their own configuration independently will be a tough thing. So what Spring Cloud provides is a Spring Cloud config server. So you can manage all the configuration for a variety of applications, for a variety of environments at a single place in a Git repository. And Git is one of the version control systems which is supported. There are other version control services which are supported as well. So all these kind of features Spring Cloud config server would provide. So you'll be able to configure applications which would be able to talk to the Spring Cloud config server and retrieve the configuration for different environments. And also one of the important things is fault tolerance. Hystrix is one of the frameworks which provides fault tolerance. Basically for each service, you would also define what happens if something goes wrong, what should it do. So that's where Hystrix comes into picture. I'll quickly, these are the 3 example microservices that we'll be looking at: currency calculation service, exchange service. The exchange service is basically you give it a USD and a dollar, it's able to say what is the conversion, what is the exchange value today. And the currency calculation service would be able to say, okay, I would want to be able to convert 100 USD into rupees. And then it would call the currency exchange service to find out what is the exchange value for USD, and it would do the calculation. I mean, this is kind of a simple made-up application. It's nothing complicated in there. And the limit service is something which would be picking up configuration from a Git repository. So when we talk about the currency exchange service, this is the kind of response it gives back, right? So you call it, it would say, okay, I would want to convert from EUR, Euro to INR. It says, okay, from EUR to INR, the conversion multiple is 75. It says, okay, it's 75. So today's value is that. And the currency conversion service, on the other hand, it would be able to take in currency converted from USD to INR and actually the quantity is not visible in here. Okay, there's a quantity, so you can say I want to convert 10 USD to INR. It would actually, here it's USD, so the conversion multiple is 65, and so 10 into 65 is 650. So this currency converter service internally would call the currency exchange service to get the currency exchange value. So this is kind of a specific deployment scenario. Let's assume that the currency conversion service has just one instance in production, but the currency exchange service has 4 instances, right? So you want to be able to distribute the load which is coming to the currency conversion service among all the instances of the currency exchange service. So that's where the important thing is, like when you have new instances of currency exchange service coming up and going down, you don't want you want the currency conversion service to be talking to all those instances. So one of the important things is location transparency. You don't need to worry about where a specific instance of a service is deployed. So if, let's say, the currency conversion service knows where the instances of currency exchange service are deployed, then when a new instance comes up, it will not be able to talk to the new instances, right? So that's where the concept of location transparency is becoming, is important. So you don't want the currency conversion service to know exactly what the instances are statically. You would want it to talk to something and find it out dynamically for each service call or at regular intervals. And so this is basically the location transparency problem, and that's where the naming server comes into picture. What happens is all the services, all the instances of the services, actually in this picture it should be the instance of each of the services which are registering with the Eureka naming server. So all the instances would register with the Eureka naming server, and whenever, let's say, the currency calculation service wants to talk to the currency exchange service, what it does is it will talk to the Eureka service, find out, okay, how many instances of the currency exchange service are present, and then it would make an appropriate call with the load distribution present. So that's Eureka naming server, and the next problem is load balancing, right? So you have 4 instances, you want to be able to distribute the load among them. So that's where Ribbon comes into picture. So Ribbon is more a client-side load balancing service or framework. So what happens is you install Ribbon along with the consumer. So the consumer over here.
Ranga is not directly going to be like a load balance. So it will just tell the client what all instances are available.
Exactly. Right. So Eureka is just responsible for kind of a service registry kind of stuff.
So every client would know how many instances are there.
Sorry?
Every client would know how many instances are there of each service.
Yeah.
So
Right.
That's absolute transparency over there.
Exactly. Yeah. So when it comes to Ribbon, Ribbon is the one which actually distributes the load among these different instances. So once you configure Ribbon on the service instance, you'll be able to distribute the load among all the other stuff. And the
So I have a question. So this Ribbon is going to get this kind of data from the Eureka server, or is there any kind of callbacks that is available to the Eureka server?
it will Ribbon would communicate with the Eureka server.
Is there any kind of callback from the Eureka server back to the
No, it's not a callback; it's more the Ribbon.
I have to manually call.
Yeah, when you want to invoke the service, you can actually talk to it and get the details back. So, Zipkin is a distributed tracing server. So, what we will do is we will create a component called the Zipkin distributed tracing server, and we can actually, like, what it does is it keeps listening to messages on a queue, Rabbit queue, for example, and each of these services can put messages on the queue. So whenever some service call happens, all the service messages are put on the queue, and all the tracing will be done here, and it will be stored to a database in memory and things like that. So this would help you to solve the distributed tracing problem. And API gateways are more like, because these services are talking to each other directly, you might not have the traceability of what's happening between them. And that's where we bring in API gateways. So API gateway, you might want to restrict number of calls to a specific service and things like that, right? So all that kind of logic can go into something called an API gateway, where you can implement things like rate limits, how many times a service can be called. You can also kind of implement fault tolerance. May not be the best place to implement it, but if let's say a service is down, if always everything is going through a gateway, then at the gateway you can kind of quickly implement a fault, some kind of a backup service just in case something is going wrong. And also service aggregation, right? So you might not want all the clients to know about each individual parts. Probably you can have a service aggregation which can be done, which will be calling multiple services and giving the response back. That kind of stuff can be done in your API gateways as well. So, and next we'll quickly look at different microservices have different configurations in different environments, and so Spring Cloud Config Server would be a solution in there. So basically what happens is all these servers, like the entire configuration for different environments for different applications is stored in Git repository, and Spring Cloud Config Server would be able to talk to them and get the respective information. So actually, like I don't think time is sufficient for me to actually give a demo. I'll quickly show you a few screens. So this is how, for example, Eureka would look like. So for example, you can see with Eureka that there are one instance of a currency conversion service, one instance of a currency exchange service, and there's a gateway server which is registered. So you can go to Eureka and find out, okay, what are the different instances which are running at a specific point in time. And this is Zipkin, where you can actually see the trace of what is happening. So you can actually say find trace, and you can actually trace the entire flow. So you can see over here that there is a currency conversion service which is calling a gateway server, and the gateway server is like the call is going through the gateway API, and it is going to the currency exchange service. So whenever you make a service call, you'll be able to see things like that. The cool part of all these stuff, the cool part of all these things is if you want to set up a Eureka naming server, all that you need to do is go to start.spring.io and create a new project, and in the dependencies, you can choose Eureka. So this is Eureka server. So in the client side, you would add in Eureka client. On the server side, you would you create a Eureka server, and that's it. That's all you need, except for a couple of other annotations that you need to add in. Or if you want to add in, like create a Zipkin server. So all that you need to do is add in a specific dependency. So all these components that we are talking about, they are just a specific dependency. Create a project, add a couple of annotations, and that's it. And you need to make a few more changes on the clients to be able to connect the client to these components. So for example, if you want them to connect to a Eureka naming server, setting up a Eureka naming server is very simple. You just create a component like this and start it up, set the right codes, and you just make a few configuration switches on the service side, and then you are ready to connect to a Eureka server. Okay, I've come to the end of this time. So if there are any questions, probably I can take them after. Okay, yeah, I can take questions for 10 minutes, and if there are more, then I would actually, let's discuss that again. Yeah, then like
what if we break down?
Yeah, you can actually have multiple instances up and running, and you can actually cluster them. So it should not be a problem.
So it's like a master slave concept of.
Yeah. So that's one of the most important challenges, right? So the naming server, the gateway, all these are centralized components. Zipkin distributed tracing. You don't want them to go down. So in those kind of situations, you want to be able to cluster them, and you want to make sure that you have multiple instances and they are fault tolerant.
Can I consider the fault tolerance as simply HTTP check calls, response, or is there any kind of other than?
No, I mean, it's like when you talk about fault tolerance with Zipkin, you can actually implement something like if let's say you are dependent on a service and that service is down. With Zipkin, you can actually very simply write code. If that service is down, I want to return a specific response back, and also that would trigger because that is being monitored, it would trigger an alert as well. So it would say that service is down. It would not impact the client because it returns a good response back. But the important thing is it would also alert people. I mean, send an alert saying something is wrong. Somebody has to look at this.
So it's like health check plus some more steps.
Yeah, it's. I would call it a health check. Health check is very basic, right? So health check is basically okay. I'm up. That's it, right? It's much more than that.
I have one question on the operational aspect. When we last evaluated, we were on two aspects. One thing is that when we bring in too many independent microservices, they evolve on their own over time. And then the problem is the contracts we build around the other services. And when they evolve, they may introduce some new services and things like that. But then the way we manage the integration across other services is becoming a challenge. So that's one operational problem.
Right.
Second operational problem is so earlier when we had to scale, right? So in the monolithic case, all we had to do was dumbly when I had more requests, either I increase the thread count or some dumb technique like that.
Right.
Now here the things would scale on their own. But then on what basis do I scale? How do I monitor each and every service on the fly? And then how do I apply the scale parameters so that if I'm scaling one service doesn't mean everything will work well, right? Because it may create a headache or a tail-end problem and I need to do so this becomes like another operational engineering challenge.
Right.
So I don't know. So
Absolutely.
So on this thing, I wanted to know what are your perspectives on these two challenges?
I think one of the most important things with microservices is you should have visibility into what's going on. Right? If you don't have visibility, then going towards a microservice architecture is not a good approach. Right? So before I have my first application live in production, I should have complete visibility into what's happening in the background for it. Without that, you are then shooting you are shooting in the blind, right? Because you don't know what's happening in the background. So that's very, very important, right? So your first question on how do you control the evolution of the microservices, I think one of the best practices there is to have some kind of decentralized governing board or something of that kind, right? So you have a number of microservices being developed. So it's very important that there is a group which is discussing what's happening, right? It's not just the service definitions itself. It would also be the tools you are making use of, the processes you are following, all that kind of stuff. You need to have somebody who's working on the thing. It should not be somebody like an architecture board, right? It's not a high-level decision authority kind of a thing. More like a kind of a group which more like a guild which kind of gets together once in a week and make sure that everything is aligned. Does that answer your question?
I think it emphasizes on having more processes in the
not processes.
in the sense like a way of communicating.
Exactly. So there should be a way where there is exchange of information around all the microservices, and also it's very important to document what is happening there so that everybody else can learn from it, right?
Probably versioning of the APIs
Right. Right. That also is an option. Yeah.
So how exactly you differentiate this from EKS or other cloud-based services? We have some cloud-based services like EKS. They have all the load balance components in auto scale.
Right. So it's basically
we have an overhead, right?
Yeah. So there are a lot of cloud providers who provide the infrastructure, which infrastructure components that the cloud provides, right? So naming server, they also provide a tracing, they also provide API gateways and things like that. So the question is whether you want to go with something you can deploy anywhere. So I can, if I'm based on Spring Cloud, then I can go it and deploy it on AWS, Google Cloud, or anywhere else, or I would want to stick to a specific vendor. That's the question. So that's the choice you need to make. Right, that's the choice. I mean, that's the choice you need to make. It's not an easy choice, but if you, like, let's say you are at AWS and you are dependent on the load balancer there, it would be impossible for you to switch to some other cloud provider which comes up, right? So that's the choice you need to make. There is no good answer to it. So are you okay with that choice or not?
Can I get
Anti-patterns. Very, like, I think one of the biggest anti-pattern is over-governance, right? So what happens is, like what I saw is, people are used to a specific way of doing things in a monolith kind of thing, where you have architecture which is predefined. That's kind of like having a governance board, big board which is deciding things, right? That's a big anti-pattern. I would rather have people who are working on the microservices having a group and deciding what's best. I mean, you would have obviously have architects inputs in there, but you would have kind of hands-on plus stuff like that. So that would be one of the biggest anti-patterns I would kind of think about. The other thing is making sure that your operations team is in line with the changes you are bringing with microservices, right? So it's not sufficient if I bring in microservices without having like the scale up, scale down. And scale up, scale down is not possible without your operations team, right? So taking care of the entire chain and not just the development part of it. That would be one more important thing that I would focus on.
These are kind of, you can say, more of a best practices.
Right. Right.
Question is more of like, what are the scenarios you go for the kind of that?
So you're asking me when you don't want to go to microservices, right? The question you need to ask, I mean, any business I would ask one question. What do you want to achieve through microservices? You should have an answer to that. So if I'm saying, like my client, he's wasting his infrastructure for 2 months. I mean, he has infrastructure which is sitting there idle for 10 months. That's his business case. So the most important question I would ask is, what is the business case? Because it's not an easy thing to go towards microservices. So what is the business case? If you're clear about it, that's the most important thing, right? So you don't just go to microservices because it's the buzzword. You go to microservices because it solves a business problem. And what is that problem? Right, exactly. So if you want to make use of the cloud, if you want to make use of the cloud, there are challenges of like how like the application. You can't just take an application which is built for local and put it in a cloud because it will not scale up. Right? So that's the biggest problem. Then you are again doing everything manually.
One of the key skills.
Okay, there is one more question.
One of the key skills of it is Microservices. So among this stack, right? Is there anything that says when your services have saturated, when your instances are saturated, and is there any means to auto scale?
Right.
Like AWS or those guys provide it.
Yeah.
So on this open source platform, we have something.
Right. So that's where your container managers come into picture, right? So like whatever we are talking about is individual instances. So all the frameworks which are used to build individual instances. You can build a container, and on top of it is your container manager, like Kubernetes, for example. That's the way you do stuff. So kind of monitoring the load does not come into the purview of individual instances, but they expose data, which will be used by.
Right. So
Yeah.
auto scaling, we need to go through Docker.
Absolutely. So the container, Kubernetes, Docker, yeah.
Yes.
Sorry to interrupt at this point. We can just wrap it up, and if there are any questions, we can just reach the speaker personally after this session.
Yeah.
Thanks for coming in.
Thank you.
Where do we get this deck?
I can send I'll share it.
I'll talk about that as well. I'll talk
Slide
about it.
share?
Yeah, it's not a slide share. I'll share it with you.
We'll actually host that deck in the ThoughtWorks GitHub repository. You can have that. So